Hello and welcome to AEC 270. This is spring 2019 and this is the first problem for group number 5. We've been assigned question 3.14 and this question reads, using the method of joints, determine the force in each member of the truss shown. So in order to start this we need to determine a few things. We'll start by looking at the angles in which the forces are acting and see if we can determine any of the reaction forces that are coming from these compressive forces on the right side of the truss. So to start, we can find the angle at the top of the truss here at AB by taking the tangent of the opposite over the adjacent, 2/4, and come out with an angle of 26.56 degrees at joint E. Down at the bottom, we can also find the angle at joint E by taking, again, the opposite over the adjacent, 4/3, and the inverse tangent to find an angle of 53.13 degrees. So using the moment at E, we can determine the reaction force coming off of the cable AB. We're going to take the distance from moment E that each force is acting and the magnitude of the force. So 2 kilos is acting 3 feet away from point E at point D, and 5 kilos is acting 6 feet away from point E at point C. We also have 7 feet away the angled force of AB coming off at 26.56 degrees. Now if we balance this equation, we find that the force of AB is 5.75 kilos in tension. Now we will move forward and solve for the forces coming off of each individual joint within the truss. And we're starting with joint C on the top right corner of the truss because this joint has 2 or less unknowns. So joint C, we'll start by looking at the y-axis and set this up as an equilibrium equation. So the angles of the joint are all at 45 degrees, and we know that there's a force coming off the bottom of the joint at 5 kilos. So if we set this equal to 0, we find that DC, which has the other y force, is 7.07 kilos in compression. Now, we'll take this forward, plug it into the x equilibrium equation, and find that BC is now acting at tension, another 5 kilos. Taking this value, BC, we can now solve in joint B, now that we have 2 or less unknowns. So we take the x equilibrium equation, we take the 5.75 kilos that we found for AB at the start of the problem, and the 5 kilos we found for BC in the last joint, and we find that BD has another x factor, and that is 0.21 kilos in tension here. Again, use the second equilibrium equation for the y-axis. You plug in the 5.75 for AB, the 0.21 for BD. You adjust for the angles at which these forces are acting, and you can find the other y component of this joint, which is BE. And BE is found to be acting 2.42 kilos in tension. Now that we've worked our way around the truss, we can come back to the main joint, joint D, with the most forces coming off of it, and take all the forces we found in the other joints and apply them to this joint. So in balancing the x equilibrium equation with 0.21 kilos for BD, negative 7.07 kilos for DC, and then using the cosine of 53.13 degrees that was found for pin E at the start of the problem, we can find that DE is the last component of force. It is 8.56 kilos acting in compression. Looking back at the overall force summary diagram, it's important to point out that these forces acting on the right side of the truss are creating compression on the members in which they're acting. In reaction to this, the opposing members will act in tension to balance out these compressive forces on the truss. This helps to reinforce the numbers and the signs that we found on each member of the truss.